Hello and welcome back to the Networking Fundamentals section of this course, where we're going over the foundations of Ethernet and Internet Protocol. In this video, we'll be covering physical cabling, some fiber and copper cabling and connectors. Although physical cabling is not directly referenced in the exam topics, I do feel it's important in your day-to-day work to be able to identify different connector types and different cable types so that you can more easily troubleshoot, more easily select spare parts, or be able to more easily replace different cable types and know which ones would work together and which ones won't. So first up, let's cover shared media versus point-to-point. Shared media networks are broadcast networks. These are your unshielded twisted pair, your standard Ethernet cables that we would find in most office spaces and home spaces today. These are your RJ45 connectors on the end. We'll be covering that a little more later. On the left-hand side, we have some point-to-point or serial connectors. Serial connectors are mostly out of style nowadays. These would often be supplied for T1 lines or other serial connections. A lot of service providers no longer provide T1 connections of having the inability to actually service and support them. You wouldn't necessarily need to commit this diagram of serial connectors to memory, though this type of connector, the V35, X21, and these things that would often look like your printer connector from back in the early 90s, that these are things that would connect into your networking devices to provide a serial connection. And the diagram indicator here is a serial connection, this lightning bolt style link. Although this is not necessarily standard, not all diagrams will show a serial connection using this lightning bolt style connector. However, many will. This is a very common way of representing a serial connection between devices. And on the right, we have a broadcast network here with 4 computers all connected to a switch in the middle, that this would be done with a shared media Ethernet connection. And let's talk a bit more about our LAN media, or our local area network media. First, in this table, we can see that all 4 of these different types start with 1000 base. This represents 1000 megabits or 1 gigabit. These are all gigabit standards. Our 1000 base T is for our unshielded twisted pair. That is this standard Ethernet type cable here. Things like Cat5 or Cat6, your category copper cables, are unshielded twisted pair cables. These have a maximum transmission distance of 100 meters. You can sometimes get more than 100 meters out of it and be okay. Sometimes you'll get less than 100 meters out of it. After about 100 meters, though, you might start encountering some transmission problems where you're getting errors on your link and not reliably transmitting your data. This is a copper media. And the second copper gigabit media that we have here is our coaxial standard. This would be the same type of cable that you saw your cable television come in back in the day, that would plug into the back of your TV with a single copper cable in the middle of a thick wire here. This has a maximum transmission distance of 25 meters, much shorter than our unshielded twisted pair. And moving over into our fiber cables, we have 2 different fiber standards here, 1000 base LX and 1000 base SX. The LX is good for long L for long and S for short, where the long is that we have a distance of 10 kilometers. This uses single mode fiber as opposed to our short using multi-mode fiber. Single mode fiber is specifically designed to transmit a single wavelength of light. This is a fiber optic connection where we have a small glass fiber inside of our actual cable here. And down here is an example of our fiber optic cable. We'll cover the connectors in the following slide, but this connector is an SC connector, whereas this connector is an LC connector. Our multi-mode only has a maximum distance of 550 meters. You can get long distance multi-mode and get longer than that. Most generally, though, your single mode will be your longer distance fiber, the type of fiber to go across city boundaries or significantly further than just another building in your campus. So speaking of fiber connectors, here are many different fiber connectors as well as the color coding of our connector and our cable itself. The important things to remember here is for your cabling, this column here, your jacket color. The yellow jacket indicates single mode, so that's your long distance fiber. And aqua or blue and orange jacket are your multi-mode. Some examples of this on the right hand side, we see we have our orange jacketing here. And then down here we see we have our yellow jacketing. That these are the multi-mode versus single mode. The difference between the aqua and the orange is going to be your OM1 or 2 versus OM3. And the difference you get in that is the distance that it's able to transmit. The very common connectors that you'll see are your SC connector here, your LC connector. And those are really your very common ones. The LC duplex up here is the same thing as just two of your LCs put together, and they're connected with a little collar here. Usually these can be split off from your collar to get two individuals. A lot of your SFPs, your actual transceiver units that plug into your switch or your router, are duplex. You can get bidirectional simplex SFPs. They're typically more expensive because they will save on the number of strands of fiber that you actually need to use. They will transmit and receive on a single strand of fiber rather than transmitting on one strand and receiving on another. Another important thing here will be your blue versus green connectors. So these two here at the bottom are both SC connectors, but one is green and the other is blue. The difference this is APC versus UPC, where APC is angle polish. Say we're imagining our little fiber optic here. Angle polish is where it's cut on an angle at the end, whereas UPC is cut into a little bit of a dome on the end, but mostly flat. So UPC is the blue, and APC is the green. A few other common connectors you'll find in older buildings will be your ST connector and FC connector. These are circular connectors that generally clip on or screw on to your fiber panel. Next up, let's take a look at single mode versus multi-mode. So single mode It's manufactured with a 9 micrometer core. So that's actually the size of the fiber optic within our cable, that this would be 9 micrometers. And it is a higher bandwidth and lower attenuation cable. You have less signal loss across the distance of the cable, which is what lends itself to having a longer transmission distance. That single mode can transmit longer distances, and it is only made to carry one wavelength very well. Multimode is typically much cheaper for the cabling and also for the transceivers. Multimode, though, is not tuned to a single wavelength. It is a 50 or 62.5 micrometer core, much larger, but it is lower bandwidth and higher attenuation. There's greater signal loss across our distance, and it is also a lower bandwidth. Multimode is PC or UPC polish, whereas single mode will come in either APC or UPC. And where multimode is used in the LAN and security systems and general fiber networks, mostly because this would be the fiber that would connect your buildings together. Remember that your UTP, your copper, only gets you 100 meters. That's not that far, whereas multimode fiber will get you 500 meters. So if I don't need to go 5 miles away and I only need my connection to be between my buildings that are only about 200 or 300 meters away, about 500 to 700 feet or so, then I might use multimode underground to connect my buildings together. And you would see this in your LAN. Whereas single mode, because of the very long distance that we see, this is used more often in telecom and CATV networks, that the telecom or provider networks are the ones that will use a lot more single mode. What's the same about both of them is that they are both a glass fiber. They can be simplex of using a single bidirectional fiber or duplex of using 2 strands of fiber, one for receive and one for transmit. And they both use many different types of connectors. You can see single mode in an FC or ST or an LC or SC connector, and you can also see multimode using those same connectors. The connector type does not in any way determine what type of fiber it is. Excellent. I appreciate you going through that with me. I hope that this has been informative for you, and I'd like to thank you for viewing.